Okay. Like arithmetic progression or geometric progression is also a special kind of a sequence. So what is geometric progression? A sequence in which ratio of, that is a division of a term and its previous term is constant. Is called a geometric progression. So examples of a geometric progression is, let's say 2, 2 into 3, 6, 6 into 3, 18, 54, 162, and so on. Can you see that's a 6 divided by 2? The ratio of a term and its previous term. What is 6 divided by 2? So term and its previous term. This is equals to 3. 18 divided by 6, term and its previous term. This is again 3. 54 upon previous term, that is 18. This is again 3. 162 upon previous term. This is again 3. So this ratio is remaining constant. This is the example of a geometric progression. The ratio that which is there means term and its previous term, that, or you can say 2 multiplied by whatever that number is. That is called as the common ratio. Here the common ratio is 3. In arithmetic progression, we were using the terminology common difference. Here we are using the terminology common ratio. Okay, this is the example. So this is a geometric progression. If I give you some example which is not a geometric progression, I think don't commit. You should not commit this mistake. Like 3, then let's or for example, yes, 3, 6, then 3, 6, 3, 6. This is not a geometric progression. Can everybody agree with me? Because here, so 6 divided by 3, second term upon previous term. Here the ratio R is equals to 2. Then here the ratio R is equals to 1 by 2. 3 divided by 6, it will be 1 by 2. Term and its previous term. So they are not same. Then R will be 2, then 1 by 2. So that is the thing that we don't want. So this is not a geometric progression. So this is not a G. Another example, if I give you, let's say 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, and so on. This is again a geometric progression. So common ratio is equals to 1 only. And common ratio can be negative also. How common ratio can be negative? I'll just give you one ratio example. So here I will just write, so R common ratio. Common ratio, the symbol is R. Common ratio is equal to 1. And the example of common ratio negative, let's say, so 6 minus 12, 24 minus 48, 96, and so on and so on and so on. Can everybody agree with me that, sir, R will here is equals to negative 2? Minus 12 upon 6 is negative 2. 24 upon minus 12 is negative 2. Minus 48 upon 24 is negative 2.
Yes, sir. Yes.
Okay, so this is the definition of a geometric progression. Now to find the nth term of a geometric progression. Since we have done with arithmetic progression, you will find geometric progression very easy. Means the concept is very easy. Formulas will definitely change, but how to derive the formulae, that part will be very easy for you. Nth term of a geometric progression. How is the representation of a geometric progression? Let's say, sir, A1, A2, A3, A4, and so on and so on and so on up to AN. This is my geometric progression. So first term is generally represented by A, not a compulsion, generally represented by A, and the common ratio is R. So the common ratio is R. So what do I know? Can I write the second term common? First term is my A. And common ratio is equals to R. So first thing, the first formula that I have is, so nth term upon its previous term. So previous term is n minus 1th term. Nth term upon n minus 1th term is equals to R. So this implies any term, that is any term nth, is equals to R multiplied by its previous term. This is the first formula in my book that we do. Any term is equals to previous term into R. So if this formula I have, second term will be what? So second term will be the previous term multiplied by R. Third term will be the previous term multiplied by R, that is A into R square. Fourth term will be previous into R, that is A into R cube. So on and so on and so on. Nth term will be what? Think for a while. It will be A R raised to, how much should I write? The power of R. Think for a while and answer. You can answer orally. R to the power what? Any one of you.
N, sir, N.
No, not n. It will be n minus 1. Okay, now if you want to determine the power over here, just compare with this. Just start from the smaller values. When it was A2, the power was 1. When it was A3, third, the power was 2. For fourth term, A4, the power was 3. Means one lesser power. Why that
And
lesser power? Why that lesser power is coming? Because see the step approach that we did in arithmetic progression, the same step approach we will do here also. So from A1 to A2 means whenever you're going one step ahead, here we are multiplying by R. So sir, from A1 to A2, you're going one step ahead means multiplied by R. So from A1 to A3, you are going, sir, two steps ahead. So two steps ahead, sir, R square, R and R, so R square. From A1 to A4, you're going three steps ahead, so R cube. So from the first step, now, so from the first step to the nth term, that is from the first term to the nth term, you have to go n minus 1 steps ahead. So n minus 1 steps ahead. So it will be R to the power n minus 1. Got it? The step approach can be used here also from second to fourth. If you know the second term, if you know the fourth term, if you want to calculate the fourth term, from the second term, just go two steps ahead. So two steps ahead will be what? So from AR, I will go AR into R square, it becomes R cube. Okay. So this is the another formula that we will have. That is AN. AN will be equal to first term into common ratio to the power n minus 1. Okay. So based on this nth term formula only, if I tell you question number 1, find the value of x if Find the value of x if these four numbers are in geometric progression. Quickly. Not getting? Come on. It's a very easy sum. Dhananjay, you also? (16x, 144 and 432). This is in GP. Not getting, Pujita? Tell me.
Explain, sir.
Okay, see. 16x, 144, 432. These terms were in AP. So, sir, I don't know that. The only thing that I know is, sir, x will be equal to, sir, 16 times. That is 16 x 144 and 432. So here it will be 16. I can just write here 16. I can write here it will be 16 times r. Here I can write 16 times r square, or since I can write 16 times r cube, or better explanation would be this is in GP. So GP is what's an upon the previous term, nth term upon its previous term. This is a constant. So, sir, x upon 16. X upon 16, I don't know, whatever that value will be. This will be equal to 144 upon x. Actually, this condition is sufficient to find the value of x. But to make your work even more easier, he had given you the direct value also of the division, 432 upon 144. Term upon its previous term, term upon its previous term, it's given. So this value turns out to be equal to 3. And this is x upon 16 equal to 144 upon x. From both the equalities, you can see that x is indeed equal to 48. Okay. Got it? Find x if are in geometric progression.
-12, sir.
Yes. Correct, Pujita? Got it? Same answer. So an upon an minus 1. An upon an minus 1. That should be this. Not this question does not deserve more than 1 minute. X upon 3, 48 upon x, and here minus 192 upon 48. So this value, actually this value we are calculating as common ratio. This common ratio is turning out to be -4. So sir, x upon 3 is -4, which makes x is equals to -12. That's my answer.
Yes, sir. I got.
If eighth term, if eighth and twelfth term of a geometric progression are 18 and 288, find the 14th term. Are you getting?
No, sir. Explain, sir.
The school method should be something like this only. The school method means the similar to arithmetic progression. So eighth term of an AP and the 12th term of an AP are given. Find the 14th term and all those things. So school term, a school method is 8 is equal to first term into r raised to 7. This is the method 1, but this is a lengthy method, but traditional one. A8 is equal to a times r raised to 7. This is a geometric progression is equals to 18. And A12, 12th term is first into r raised to 11. This is equals to 288. Now a r raised to 7, a r raised to 11. Don't think of subtracting them. Now we will do the division. Here in geometry, the only difference in AP and GP is in AP GP. We are mainly dealing with the operations of plus and minus. In GP, we are mainly dealing with the operations of multiply divide. So on dividing, so A12 upon A8 is equals to A r raised to 11 upon A r to the power 7. This is equals to 288 upon 18. This turns out to be equal to, sir, r raised to 4 is equals to, this is 18 ones are 18 ones are 18, and this is what 10, 100 and 8, 18 six are 16. So r is either equal to 2 or either it is equal to -2. Got it? R is to 4 is 16. So r can be positive also, negative also. We don't have a problem. Now r equal to plus minus 2. So that we have. So now what is this? 14th term. 14th term is what now? So 14. R equal to plus minus 2 first. Then you have to calculate a also. This a. But that is unnecessary method. So r equal to plus minus 2. And now 14th term. So 14th term can I calculate from here? A14 is equal to, don't use the formula first term into r raised to 13. No need. Why are you starting from the first term? Start from the 12th term. That value is already given to you. From the 12th term, 2 steps ahead. 2 steps ahead means r square. So what is the value of the 12th term? 12th term is given to be equal to 288. No, 12th term is given what? Yes, 288 only it is given. And multiplied by r square, and r square is 4. So A14 is equals to 115. Got it, Pujita?
Yes, sir.
And here then method 2. Actually method 2 highlight is you should just be able to directly write this step. A12 upon A8. A12 upon A8. This you should directly be able to write r to the power 4. How? This method I am approaching. So 14th term, from the 12th term 2 steps ahead. Similar on the similar line. 12th term from the 8th term. How many steps ahead? 4 steps ahead. So r to the power 4. 4 steps ahead, r to the power 4 is equals to the direct division 288 upon 18. This turns out to be 16 and so on. Got it?
Yes, sir.
1 minute time for this question. Okay, you can. Okay, now don't use calculator. If 5th and 8th term of a geometric progression are 12 and 324, find the 9th term.
Sir, 27, sir.
No, 9th term I'm asking. 27 is not the 9th term. Dhananjay, are you getting?
Sir, 972, sir.
Yes, now it is correct. 972 is correct. So 8th term and 5th term, I have the relation. 8th term is from 5th term, it is 3 steps ahead. 3 steps ahead means a5 into r cube. So using this relation, 324 is equals to 12 multiplied by r cube. So r cube turns out to be 324 upon 12. 324 upon 12 is 27. So r is equals to 3. No choice of minus here. It has to be 3 only. No choice of negative 3. And now ninth term. Ninth term, how to calculate? From the eighth term only I will calculate. Ninth term is what? So A8 into R. So A8 is given to me with 324 multiplied by R. So this turns out to be equal to 972. In a geometric progression, the 10th and 20th term are 324 and 625. Find the 15th term. Are you getting? there is a catch in this problem. I will give you a hint. Like previous questions also you can do, not an issue. But if you understand geometric progression, arithmetic progression, geometric progression, similar approach only. Use the step approach. The 10th term, 20th term, 15th term, those are not some random values. Those are some very nice values. 10, 15, 20. Think in terms of steps, how that will be. Are you getting Dhananjay and Pujita? Shall I explain?
Explain, sir.
Like the previous methods only, if I did 820 from the 10th term, it will be r raised to 10. 10th term into r raised to 10 will be the 20th term. So, sir, r raised to 10 will be equal to 20th term upon 10th term, that is 324. Till here, I think both of you would have got the result. Okay. So now,
Yes,
sir,
sir.
we definitely cannot find the 10th root of this 625 upon 324. That is a very different, very absurd, means a very complicated surd. So let it be up till now. Till this step, just leave it at this point. Don't need to calculate the exact value of r. It is some kind of surd. 625 upon 324 whole raised to 1 upon 10. The 10th root. Let it be as it is. Now we have to find the 15th term. Okay, so 15th term is what? So 15th term, in order to calculate the 15th term, what I will be doing is, so from the 10th term, I will be going 5 steps ahead, that is r to the power 5. R to the power 5 means what? Who got the answer? Yes, 450 is the correct answer, Dhananjay. So from the 10th term, I have to go 5 steps ahead, r to the power 5. So 324 multiplied by, now r to the power 5. So r to the power 10, I know the value. So by that, actually, I can find the value of r also, means the 10th, but that is a little complicated. Without going into that complication, can I calculate r to the power 5 without going into that complication of finding the actual r? Yes, sir, I can calculate r to the power 5. How? Because r to the power 5 and r to the power 10, they are related. R to the power 5 is square root of r to the power 10. This is something like r to the power 10, its square root. Raised to 5 means what? Raised to 5 means raised to 10 whole raised to 1 by 2. So now it's just substitution. This is 324 multiplied by r raised to 10. This value I know. What is this value? 625 upon 324 complete to the power half, that is under root. So what comes is, this is 324 multiplied by 625 under root is 25 upon 24, 324 under root is 18. So this is, sir, 18 ones are 18, 18s are, and 25 into 18, 25 into 18 turns out to be equal to 450. Got it, Pujita?
Yes, sir.
There is a better approach. In fact, there is a property for this question. Derive a result from this question. What result you can derive? My claim is that the 10th term, the 15th term, and the 20th term, they themselves form a different geometric progression. My another statement is, so my 10th term, 12th term, 14th term, 16th term, 18th term, and 20th term, 10, 12, 14, 16, 18, 20. These five together form a different geometric progression. How am I reaching at this result? So see. Method 2. So sir, it is something like you have A10, A11, A12, A13. Okay. Now each jump is of R units, means by multiplication. Each one step jump is of a multiply by R units. So sir, if I do a jump of 2 units ahead, that will be so each consecutive terms, they are all separated by a multiplicative factor of R. So we call them a geometric progression. So if I take equidistant term, for example, if I put my points over here, let's say equidistant from, I start from A10, then I leave one term and I took A12, then I leave one term, I took A14, then I leave one term, I took A16, I leave 17, I took 18, leave 19, I took 20. Whether they themselves will form a GP, yes, they will form a separate GP. A10, A12, A14. Can you see that each time the common difference is same, only R means same, means the difference, the ratio is in the consecutive terms is R square now. Different from the previous GP, but it is still a common ratio. This is again a geometric progression. This is a new geometric progression. 10, 12, 14, 16, 18, 20. Where the common ratio is of R square. R square, R square, R square, R square, R square. Can you see this thing? So by that conclusion only, I can also take that's a A10, A14, A17, A20, A14, A18, A22, A26. This will again be a GP, a new one, even more new. Here the common ratio will be R raised to 4. The original common ratio R that we have, R to the power 4, R to the power 4, R to the power 4, R to the power 4. Is this point clear to you? What I'm trying to say? Means I'm forming a new sequence. Which is my new sequence? The 10th term of the original one, the 14th term of the original one, the 18th term of the original one, the 22nd of the original, 22nd of the original one, 26th of the original one. These I'm taking as the consecutive terms, and these are the consecutive terms of my new sequence. And these consecutive terms, the common difference, the common ratio, the common ratio is same. Can you see? It is R to the power 4, the original R raised to 4, original R raised to power 4. So
Yes, sir.
by this observation, if I just write the result in method 2, sir, A10, A15, and A20 are in GP, geometric progression. 10 to 15, whatever units you are going ahead, 5 units ahead, that is R raised to 5, the same ratio of R raised to 5, you are going from 15 to 20. So this result I will use. So this result I will use that A20 upon A15 is equal to A15 by A10. A15 by A10, term to previous ratio is same. A15 upon A10, I don't know. A15 upon 324 is equal to, sir, A20. A20 is 625 given to me, and this is again A15. So, sir, A15 is turns out to be equal to 625 multiplied by 324. This is A15 square. So to avoid that, to remove that square, I will take the complete under root. So the same value we get, 25 into 18. Okay. So if you would have been clear with the step approach, this is the most important line in that 8, 10, 15, 10th term, 15th term, and 20th term. This is these three terms successively, they will be in GP. If you are able to realize this, then it's just 2 steps from them. See the calculation that we did on the LHS and see the calculation that we did from here, this part. Got it? So the result, this result which is there, 8, 10, 12, 14, 16, 18, and so on. I will write the generalized result, remark. Okay. After I will just write the remark. You take the screenshot of remark and the screenshot of the previous questions. Just 2 minutes after. So the remark is, if A1, A2, A3, and so on and so on and so on, AN is a geometric progression. Our terms in a geometric progression, then the Pth, Qth, Rth, Sth terms are also in GP, where P, Q, R, S are themselves in AP, not GP. Keep this in mind, because we want PQR as a Pth term, Qth term, Rth term, Sth term. Means AP, Pth term of the GP. We are considering the sequence, the original sequence is a geometric progression. Okay, in the Pth term of the original GP, Qth term of the original geometric progression, Rth of the GP, and the Sth of the GP. This will be again a new geometric progression only. The only thing is this PQRS are themselves in AP, like that we did over here. We are taking equidistant. Equidistance, we are taking equidistance. 10, 12, 14, 16. This means PQRS is what? So P is 10, Q is 12, not A10. Keep this in mind, okay? There is a difference between 10 and A10. 10 is a number 10 and A10 is the 10th term. 10, 12, 14, 16, 18 as numbers, they are in arithmetic progression, arithmetic. And the A10, A12, A14, A16, these are the geometric progressions. They are not equally spaced on the number line. 10, 12, 14, 16, 18, 20, they are equally spaced on the number lines. Got it, Dhananjay? Okay. After I take the screenshot quickly of the remark also, and I will scroll down for you. After I done screenshot, Hello, Afrin.
So your
I'm
voice
moving
is
ahead now.
breaking.
Voice is breaking. Actually, for
It
few
is
days.
okay, sir.
If it's okay for some people, then the problem is not from my side. Okay.
Okay. Sir.
So this was the geometric progression. Some few questions. How many questions have we done? Question number 5. The next question. Question number 6. Insert two numbers in between 15 and 916 such that all of the numbers are in geometric progression. Okay, Afrin. You can take the screenshot at last also. Not
Okay, sir.
Getting like terms of an AP only. Insertion of terms in between an AP such that the new sequences again insert numbers between and two fixed numbers.
So 60 and 240.
Yes, correct. C. Pujita and Afrin. When two numbers are inserted, like the concept in AP only, so two numbers are inserted, so the interval will be divided into three parts. If 10 numbers are inserted, we are breaking that ribbon into 11 parts. Okay, so it's something like here. Two numbers are inserted. So two numbers are inserted here. It is 1 and 2. Now they are not equally spaced. Equally spaced concept was in arithmetic progression. Here the concept is not of equally spaced. It's just multiplicative factor is of r, and but two. So the total steps that you are taking. So two numbers are inserted. So from the starting point to the end point, you will have to travel a distance of r cube. Do you realize this thing? Pujita and Afrin, do you accept with me? Do you accept this fact? From 15 to 960, I will have to travel sir, r 3 times, so it will be r cube.
Yes, sir.
If 10 numbers are inserted, so actually 10 numbers inserted means that ribbon is cut into 11 pieces. That ribbon is cut into 11 pieces, so you have to travel a distance of r to the power 11. The multiplicative factor from first to last is r to the power 11. So r cube. So r cube equal to 960 upon 15, or 960 upon 15. So r cube is equals to 64. So r is equals to 4. So what are the terms? So first term is 15. Next term is 15 multiplied by 4. It will be 60. The next term will be 60 multiplied by 4. That turns out to be 240. Next term should be 240 multiplied by 4. 960. Yes, sir. It matches with the final destination. So we are correct. Okay. Similar lines, new question. After R3 means we are multiplying either successive terms, we are multiplying by R. Na? 15 into next term, what it will be? So next term will be 15 into R. What will be the immediate next term? 15 into R into R. That is 15R square. So what will be this term? 15 into R into R into R. That is R cube. So this R cube is 15 R cube is 960. 15 into R cube is 960. Insert three numbers between 16 and 1296 so that resulting sequence is a geometric progression.
So is it 48, 20, 24 and 432? 144 and 432, sir.
144 and 48, 144,
48,
and then
144, 432.
yes, correct.
Yes, sir. Same. I also got, sir.
Yes, correct, correct. So starting point to last point, 16 and 1296. So 3 numbers are inserted. So I have to go 4 steps ahead to reach my destination. There are 3 stops in between. So the multiplicative factor is r to the power 4. Okay, Afrin also got the result. So all 3 of you got it. So r to the power 4, 1296 upon 16. This turns out to be 81. So r is equals to, actually here it is plus or minus 3. Fourth root, whenever you're taking the even number root, so plus or minus 3. So it's just a slight correction, nothing, but your answer is correct only. So GP1, the 3 numbers that I can insert is a 16 in 16 threes are 48, 48 threes are 144, 144 threes are, this will be 432, and into 3 it indeed it checks out to be equal to 1296. I will have to include the previous ones also. 16 this and then 1296. This indeed it's a sequence, and 16 minus 48, 144 minus 432, and into negative 3 into negative 3. What? Let's check the answer. It turns out to be equal to 1296. Yes, we have reached our destination correctly. Okay, so just a minor correction. So generalized result. So what is the generalized result? Insertion of n terms between A and B to get a geometric progression. A and B are fixed and n terms are resulted in between. This is my A, this is my B, and n terms are inserted. I'm denoting those n terms as T1. Okay, now here slight caution, note of caution, that if I'm referring the final result that I will write, that if I'm writing the nth term, so you should be careful that nth term formula that you're writing, that nth term you're counting from this part means the terms that you have inserted, that you have counting as the first, second, third, fourth, fifth, sixth, seventh, and so on, or you're counting, let's say, a 10th term. 10th term you should count from 1, 2, 3, 4, something like that, or so this whole thing is a geometric progression. So this whole thing is a geometric progression. So sir, I will include A as the first term. A is my first term. So then 1, A is my first, 2, 3, 4, 5, 6, 7, 8. So the actually that will be the new terms that we have inserted. Among the new one, that will be the 9th one. 9th new term is equals to the 10th of the complete one. So that's a slight difference. So if you're talking about 10th term, be careful. Means in the question paper, what 10th term he is asking, be careful in that. So here I am denoting it as T1, T2, Tn. In the purple one, we have denoted as T1, T2, T3, T4, Tn. So by now, I think you should be able to realize. I will write the result directly. So the common ratio will be equal to B upon A complete 1 upon n plus 1, means the n plus 1th root, because from A to B, while going from A to B, so n terms are inserted in between, so we have to go n plus 1 steps ahead. N plus 1 steps ahead means we are multiplying by r to the power n plus 1. That is the multiplicative factor. Okay, r to the power n plus 1. So from r to the power n plus 1 is b upon a. So r equal to b upon a raised to, means b upon a, it's n plus 1th root. Got it? So sir, now my pth term. Now here I've used the color also, so be careful. My color, my counting is from the new terms that I am inserting. The new terms that I am inserting, that is my counting process. So my counting process, the new terms only. So from the a, according to the new terms, a is the 0th term. So 0th term. So from a, I have to go p steps ahead only. A into r to the power p. So that will be equal to, sir, a multiplied by r. What is my r? B upon a raised to 1 upon n plus 1. 1 upon n plus 1. That is this r to the power p. So it will be p upon this. Are you agreeing with the result? These two formulas. Is it clear to everyone?
Yes, sir. Yes, sir.
Afrin Dhananjay. Now the next part is sum of n terms of a geometric progression. Okay. So what is my geometric progression? So a1, a2, Sn. Sn is equals to a1 plus a2 plus a3 to the nth term. So it is something like, sir, Sn is equals to, my first term is a, my second term is ar, third term is ar square, fourth term is ar cube, so on and so on and so on. My last term is a times r to the power n. Okay. Now, if you are thinking that, sir, I will write this in the reverse order, like we did in arithmetic progression, that will not be of any help to us in this case, in geometric progression. So let's write Sn in the reverse order, so that here I will write ar to the power n and ar to the power n minus 1 and ar to the power n minus 2. Here it will be a. Now, if you add this, here it will be a common 1 plus r to the power n. If you do add these two, you get ar as common. Ar plus ar to the power n minus 1. So ar, if you take common, 1 plus r raised to n minus 2 it will be. Okay, r raised to n minus 2. If 1 r, if you take it outside, so what remains is r raised to n minus 2. So here ar common 1 plus r raised to n minus 2. Here it is 1 plus r raised to n minus r raised to n. And here it is something different. This method does not work. That I will just write Sn in the reverse order. So what's the correct approach? This Sn, I will write again, but I will with a small difference. Instead of Sn, I am writing by r times Sn. I am multiplying this Sn by r, the common ratio. So r times Sn will be what? So first term will be ar. So ar I will write over here. Means this way. I've shifted the sequence one step ahead. I've shifted the new term here. ar into r will be ar square. This ar square into r will be ar cube, and so on. It will be shifted ar to the power 4. So this ar raised to n, this will be shifted a. 1 minute, I've made some mistake. Yes, this nth term, students, this nth term is a r to the power n minus 1. That is the blunder that we committed. Nth term is a r to the power n minus 1. Okay, that was the last term. So that term, when it will get shifted ahead, it will become a r to the power n. Okay, got it? And this is all in addition only, r times Sn. The previous here also downward will come a r to the power. Previous was r raised to n minus 2. Here it was r raised to n minus 2 multiplied by r. It will become r raised to n minus 1. Now our work is easier. Now subtract them. If I do a complete subtraction, so what happens? It becomes Sn as common, and it becomes 1 minus r. It is equal to, so this a will survive over here. This will be the surviving factor. Here a r raised to n will survive, and rest everything will get cancelled out. So a and this plus here it is there, but it will become minus a times r to the power n. Rest everything will get cancelled out. Do you see? Okay. So now before this is up till now no problem. This is equal to up till now no concern. The next step there is a star mark condition. The next step there is a star mark condition. This step is universally true. 1 minus r into Sn is equals to a minus a r raised to n. The next step is Sn. I can write a common 1 minus r to the power n divided by 1 minus r. If and only if r is not equal to 1. Because if r becomes 1, then it is division by 0. The previous step, it is 0 times Sn and a minus this. So how can you divide by 0? Not possible. So this formula is true if in the proof part, if you're not multiplying by 1. So what if the common ratio is 1? In that case, can't we find the sum of the sequence? If the common ratio is 1, so then the sequence is very easy. It's a trivial sequence. A is being repeated. So in that case, you no need of any formula. Got it? Just a is being repeated n times. So n multiplied by a is the sum of the sequence. It is still a geometric progression, but some Sn will be no need of high-fi formula. Just n times the a, n times the whatever that term is. Okay. So Sn is equals to a times 1 minus r is to n. This is also written as, so Sn two formulas means it's actually one formula only, but two different ways of interpreting it, that formula. R to the power n minus 1 upon r minus 1, which is again equal to the previous that we got, a 1 minus r raised to n upon 1 minus r. Okay. This generally we use when r is greater than 1. Generally use. So because the denominator is positive, r minus 1 and r is to n minus 1. And this formula we generally use when magnitude of r is less than 1. Magnitude of r means it's a proper fraction between 0 and 1. Got it? This is the result of Sn. They both are one and the same thing. I just multiplied the numerator and denominator by minus 1 and minus 1. One and the same result. Okay. Clear till this point?
Yes, sir.
Afrin, have you taken
Yes,
the
sir.
screenshot? Can I move ahead? Okay.
Yes, sir.
Okay. So now previously how many questions? Find the sum up to n terms of the sequence 2, 6, 18. So it will be a formula of n. So what is the first term? First term is equals to 2. What is the common ratio? Common ratio, you can observe it is equals to 3. So what is Sn? So Sn is a times r to the power n minus 1 upon r minus 1. Use this formula when r is greater than 1 to avoid negative denominator. And if r is less than 1, we use the other one. So it will be simply 2
Sir, is
times,
the answer 2?
no, 2 times, it will be 3 to the power n minus 1 upon 3 minus 1. So it is equals to 2 multiplied by 3 to the power n minus 1 upon 2. This gets cancelled out. So Sn is equals to 3 to the power n minus 1. That's it. Means you have developed a machine now. You have developed a formula, you have developed a machine. So you give us n, I will give you the input n, you will give me the output. A sum up to n terms. If I tell you find the sum up to 10 terms, so just put 10 here, 3 raised to 10, whatever that value is, subtraction 1. If I give you 100 terms, just put 100 in the input as in this machine, 3 raised to 100, subtraction 1. Okay. Ujita, you missed this n over here. That's why you cancelled 3 minus 1, 3 minus 1. That cannot be cancelled. This is 3 raised to n minus 1. Okay. This factor, this bracket in the numerator and this factor in the denominator, they are not equal. They are different. Okay. In a sequence, if first and fourth term are two and 250, find the sum of all the terms up to 250. I'm not telling 250th term. I'm telling terms up to 250. Done, students?
Yes, sir. 312, sir.
First term and the fourth term. This is 2, this is 250. So first term and fourth term, so that is a journey of 3 steps. 1 to 4, that is a journey of 3 steps. So r cube. Okay, the multiplying factor is r cube. So r cube equal to 125. So r is equals to 5. So we are calculating first to fourth. First to fourth is S4 is equals to A is equals to 2 multiplied by r to the power 5 to the power n minus 1 upon r minus 1. So this turns out to be equal to, this is 625 minus 1 is 624 upon 4. This is 1 za, 2 za. So this turns out to be equal to 312. This was the answer that you got. Dhananjay, Pujit, Afrin, did you get this answer? Different one. Answer me, students.
So same answer, sir.
So okay. This question number 9. Okay, so we'll stop here for today. The next part we will continue tomorrow. Tomorrow Saturday. Saturday we'll do the series part.